Hello everyone. Welcome back to Topics and Problems in Higher Mathematics. Today's problem of discussion is the following. Prove or disprove the following statement. Let an be a sequence of positive real numbers such that this series summation n is equals to 1 to infinity an to the power 3 by 2 is convergent, then series summation n is equals to 1 to infinity an divided by n is also convergent. So what do you think? This statement is true or false? If you would like to give it a try, then pause the video here and when you are ready, keep watching to know the answer. We claim that the above statement is true. In order to prove it, we will use Holder's inequality. So let's recall the Holder's inequality. So Holder's inequality. This inequality is stated as follows. Let ai and bi are positive real numbers for I is greater than equal to 1 and less than equal to n, and we have two real numbers p and q lies between 1 and infinity be such that 1 by p plus 1 by q is equal to 1, then we have summation n I is equals to 1 to n ai bi is less than equal to summation I is equals to 1 to n ai to the power p whole power 1 by p times series summation I is equals to 1 to n pi to the power q to the whole power 1 by q. And if we have those PQ real numbers which satisfies these two conditions is known as Holder's conjugates. Okay, so Holder's conjugate. So if we have two real numbers PQ which satisfies the condition that P and Q lies between 1 and infinity and 1 by P plus 1 by Q is equals to 1, then PQ is known as Holder's conjugates. Okay, now coming back to our problem, consider the kth partial sum of the series summation n is equals to 1 to infinity an to the power n. That means the kth partial sum of this series. So the kth partial sum is nothing but summation n is equals to 1 to k an divided by n. We can write it as summation n is equals to 1 to k an times 1 by n. Now take p is equal to 3 by 2 and q is equals to 3. Then 1 by p plus 1 by q is nothing but 2 by 3 plus 1 by 3 which is equal to 1. That means p and q are Holder's conjugates. So therefore that means we can apply Holder's inequality for this value of p and q. So by Holder's inequality, summation n is equals to 1 to k series summation n is equals to 1 to k an times 1 by n is less than equal to series summation n is equals to 1 to k an to the power p whole power 1 by p times series summation n is equals to 1 to k 1 by n to the power k q sorry whole power 1 by q. Now substitute value of p and q here. We will get summation n is equals to 1 to k an to the power 3 by 2 the whole power 2 by 3 times series summation n is equals to 1 to k 1 by n to the power 3 whole power 1 by 3. Since the sequence of partial sums of series of positive real number is increasing, so we have this is less than equal to summation n is equals to 1 to infinity an to the power 3 by 2 to the whole power 2 by 3 and summation n is equals to 1 to infinity 1 by n cube to the whole power 1 by 3. Ultimately, we are just adding the positive terms. So obviously the when we are adding more positive terms, the summation will be greater. Okay, so this thing we are doing here. Now taking k tending to infinity, because this statement is true for each and every k. So if we can this statement is also true for bigger k. So let's take this k tending to infinity in the left side of the inequality. We get summation n is equals to 1 to infinity an times 1 by n is less than equal to summation n is equals to 1 to infinity power 3 by 2 whole power 2 by 3 1 by n cube power 1 by 3. Now by the hypothesis we know that an's this is convergent and one a series 1 upon may n cube is also convergent, because we know that summation n is equals to 1 to infinity 1 upon may n to the power p is convergent if and only if p is greater than 1. So this is also convergent. So their product is. So that means this is also convergent. Okay, so that means our claim is proved. So let's see the statement again. So if a and b are the sequence of positive real numbers such that the series summation n is equals to 1 to infinity an to the power 3 by 2 is convergent, then series n is equals to 1 to infinity an divided by n is also convergent. I hope you understand the question and the solution. Thank you so much. Bye.